Rakkiyappan. Hello, I understand your camera isn't working, so if you see me,
Hi. Yeah. Hi. Thank you
wonderful to
so
have you.
much, first of all. Uh-huh. Am I audible?
Yeah, we hear you. We hear you well. So,
Thank you. Thank you so much. I really appreciate for giving us this opportunity for the Tech Break presentation. And I've been looking all the presentation. It's really amazing to know a lot of various technology and get to
great,
know about where we can also do a lot of collaborations.
great to have
So
you.
uh, I work here in Supreme. Supreme is, I'll just give a background of Supreme is a um, textile company which makes cut resistant, abrasion resistant, and slash resistant, and all high tech clothings. And we have brands like Tough and Light. We have another brand like Light and Cool, etc. These are all few of our brands that's been there in the market. And we are trying to move into another sector of project, which is moving towards the more therapeutic application using textiles. So we came up with a material which can have as a multifunctionality process. That's where we started using it for more thermoregulating and therapeutic application that could be done. So in this technology which I'm going to present today, it's basically creating a platform which is like multifunctional nano platforms. So I was very much specialized on photodynamic therapy, which is uh, trying to understand how a photon or how the visible light can activate certain dye molecules to give certain functionalities. So when I was working in photomedicine lab at the Massachusetts General Hospital, I used to work with a lot of thiazinium dyes and azo dyes and etc. And we try to have a platform where we try to encapsulate them with certain nanoparticles, providing them with multiple applications. So trying to create a multifunctionality which can even be for imaging applications and other application, and we can tune those particles based on what we needed. So looking into this multifunctionality application, when I started working at Supreme, I pretty much was surprised. Like we pretty much use dye molecules in dyes for coloring the textiles. So I was thinking, how can I apply this dye technology with the aim of having a therapeutic application? So when we see the dye molecules, sorry to move for the other slides, but when we see the dye molecules, which we can do with different shades and colors, we wanted to use this dye molecule for a therapeutic process, and then I synthesized few nanoparticles to embed them on these dye molecules to have certain functionality on the textiles. So when we see the electromagnetic spectrum, um, you can see how important it is to have the visible light and also the near infrared light. And it's very much from when we see the range uh, for the visible lights, and when we go for the near infrared, very close to 730 nanometers, further to close to like 1 2 3 microns, we see more of the infrared, near infrared region, where it has a very good synergy of process things happening. So the light is very, very important for this application of what we're trying to do with this textile material. We're trying to integrate light with a dye molecule to activate the process to give a therapeutic application. So when we see the effect of IR radiation on human skin, when we see the near infrared, the shorter infrared wavelength, they actually penetrate to the skin epidermis layer. This was one of the paper that I published in 2013. And during this work, we try to understand how different light sources are really playing an important process onto the textiles, onto the skin application, where I can integrate into the textiles. So they can really, the near infrared really stimulates the collagen, elastin production, etc. And they also promote skin renewal. And likewise, the mid infrared have different other applications, and the far infrared. There have been a lot of in market having influence of the far infrared application into the textiles, which is kind of a process, but we're trying to look more of a near infrared region where we're trying to activate onto the surface of the skin. So looking into this application, um, I try to understand how the textile materials are been having the influence of the IR effect. Human skin, when we see, it's an excellent IR emissivity and it has an emissivity of 0.98. So when we see the human body emits IR radiation in the way